All right, hello everyone. Welcome to the second webinar in the series of webinars on Azure for IT professionals. We have with us today the one and only Kristian Nese. I hope I got the name correct, from the Azure CAT team at Microsoft. So in today's session, Kristian will take us through the Azure Resource Manager for IT professionals. So it's all yours, Kristian. Let's get started.
Thank you very much, Robbie. Let me try to steal your presentation and share out my desktop. Can you just confirm that you can see it?
It's coming up.
Is it loading?
Or? Yes, I can see it.
Okay, excellent. So I think we're all set. So hi everyone, welcome, good morning, good evening, depending on where you are. My name is Kristian Nese. I'm part of Azure Engineering. More specifically, I work on the Azure CAT team, which is the customer advisory team, where we engage, I would say, with some of our most demanding customers. And personally, I engage on topics such as Azure management and especially Azure Resource Manager. So I'm delighted to be here virtually this morning, my time. Before joining Microsoft, I was actually an MVP for 5.5 years, and I really appreciate the community effort and the things going on there. So I'm glad to be here to present about on Azure Resource Manager today. So the topic, of course, is on ARM, more specifically for IT pros. So whether you are new or you have experience with Azure Resource Manager already, I think there should be something in there for everyone. So let's see how this basically goes. So the agenda I have prepared for today, we have about 1 hour, but I also want to ensure we have time for Q&A as well. So please use the IM window whenever you feel you want to bring up a question, and I'll try to answer as good as I can. So Azure Resource Manager has been around for a couple of years now. So I almost assume that everyone knows at least what it is and where it belongs in the context of Azure. So I will focus a bit on some of the new capabilities that we introduced within Azure Resource Manager, and also go through that in the context of some real world scenarios. But of course, if you're completely new to this, we'll also ensure that we have a good, solid understanding of Azure Resource Manager in general before we actually start to dive into some of these capabilities as well. We'll also touch on how you can use ARM to govern, control, and manage access across Azure as well. So those are kind of the 3 topics we will touch on during this presentation. So once you leave this presentation today, hopefully you have a feeling that, wow, I at least now know what Azure Resource Manager is, and you have a happy face on. You will understand that you can configure, deploy, and manage Azure at scale using Azure Resource Manager, that you can service your applications, your infrastructure, your management services, and the entire topology using ARM, and also to govern the subscriptions, the resource groups, and resources as well. So those are kind of the key takeaways from joining this call. All right, so let's get started and talk a bit more about Azure Resource Manager. So this slide hopefully shows the overview and the architecture of the things we're dealing with here. So Azure and also now Azure Stack will have the same front door API, which will be the Azure Resource Manager. So whether you are using ARM specifically today to create and deploy templates, you're obviously using the Azure Resource Manager API, but also whenever you go to the portal or you make an imperative call using PowerShell, CLI, or any other clients, you are in fact using Azure Resource Manager to handle all the requests as well. So it sits as a front door across on top of all the different resource providers we have in Azure, whether this is Microsoft.compute, Microsoft Storage, Microsoft Network. They have the different resource provider namespace, which also includes one or more resource types. So we use Azure Resource Manager to authorize and access the different resources. So everything is taking place throughout this console plane. So the resource provider contract you see below, we have, as I said, we have resource providers for basically all the different resources you see in Azure. So whenever you see a new service coming in Azure, it's most likely a new resource provider under the hood, which has one or more resource types. So to show you an example of a resource provider and resource type, we have the Microsoft Compute namespace, which sits on the virtual machines, and the availability sets. We can also have nested resources within virtual machines, such as extensions. If you have ever created a recovery vault, you are dealing with the Microsoft recovery services and the vaults resources. And for automation, if you ever have created runbooks, you have an automation account, and then you have nested resources within the automation account namespace, such as runbooks, modules, and variables. So before we got to this place where we now have Azure Resource Manager, we all know that we came from the classic model, as I referred to here. So in the classic model, which means the old Azure portal, we had a very simple concept where we had the notion of a cloud service. So the cloud service was basically the logical container of the virtual machines you created. So whenever you created a virtual machine, it had to belong to a cloud service. So the cloud service can have one or multiple virtual machines, but in this case, in this example, I want to call out the different resources involved for you to instantiate a virtual machine. So cloud service, you had a virtual machine that also had a disk located on a storage account and eventually connected into a virtual network, and more specifically a subnet. You could then also have a load balancer with an IP address, and this basically concludes what you had to do to instantiate a virtual machine in the classic model. If we pivot into Resource Manager, which is where we are heading for now, we don't have the concept of cloud service, but we have a resource group. So everything you deploy into Azure needs to belong to a resource group and can only be part of a single resource group. So the different resources you see, the purple boxes here, are all the required components in order for us to instantiate a virtual machine, similar to what we have on the left side using the cloud service model. What's also interesting here is that with Azure Resource Manager, you can send async calls and deploy things in parallel as well. So potentially you can deploy all the resources you have in parallel. However, I want to call out some of the important things here is that when you have a lot of flexibility with ARM, as we will look closer to, it also comes some responsibility with it. So to create a virtual machine, you also need to define the dependency graph throughout the deployment. So the first thing you need to have deployed is a storage account, and the virtual machine will basically have a dependency on this storage account, which means we won't deploy the virtual machine before we have successfully deployed the storage account. We also see that the virtual machine can have references to other resources. In this case, the network interface card, so it has an implicit dependency on that, meaning we can't create the virtual machine before we have created the network interface card. The network interface card itself also has another reference to an IP address, which is its own resource, and also a virtual network with the subnet. And also the load balancer, as you can see, goes to the NIC, and the load balancer itself also has an IP address. We can then also reference a network security group in order to have a software firewall in Azure. So as you can see, this might get complex over time as you start adding resources to your templates to declare the topology of your application and services. So you need to be aware when does one resource depend on another and vice versa. Apologize. Can someone mute their mic? I'm getting some feedback here. Okay, thank you very much. So To summarize, in the version 1 of Azure, as we saw, we were lacking support for things such as RBAC, tagging, and templates, and they were basically not the way forward. In version 2, which is Azure Resource Manager, as I referred to, resource providers are fully integrated to ARM, and this is where all the effort from our side is located from an engineering perspective in these days. So ARM will handle all the resource providers through the control plane with async and parallel operations that will essentially boost your deployment scenarios compared to the classic model. It's also worth to call out that this is part of the Azure consistent message we are bringing. So with Azure Stack, we also have Azure Resource Manager present there. So ideally, if you work on templates and we have the same set of resource providers available in Azure Stack as we have in Azure, you could potentially take the same template and deploy it towards an Azure Stack environment and have your resources deployed. So what does it mean by deploying with Azure Resource Manager? So everything you can deploy with ARM is potentially template driven. This means that you can create a template and bootstrap your environments, your applications, your resources, and now essentially the entire topology in the cloud. As you will see as we go through this in more detail throughout the demo, you can also parameterize the template and make it usable for others as well. The template model that we have and the template language expression, it's itself declarative and idempotent, which means you can define the exact state of your template and resources and deploy it over and over again. So in other words, it will ensure that the resources are in its desired state, and also simplify the update process of your resources by deploying the same template again, only with different values. So some of the new capabilities we have added, such as serialized copying, means that you can essentially use a template to service existing resources that you already have deployed. In this deck, we also call out it's multi-service, which means if you have a template, you are free to include any resource you might want to use in the template. So you're not limited to only deploy virtual machines or IaaS-specific services, but you can combine and also use any of the other Azure resources that's available. And this is interesting because instead of creating these individual resources that you might have done earlier, and later stitch them together, you can now create templates that deploys all of this and then can stitch it together during runtime of the template. We can also extend, meaning that if you have virtual machines or if you have web apps or SQL databases, you can actually leverage extensions. So you can walk the extra mile, to put it that way, and interact with the different services at the data plane to configure it to its desired state. Also worth to call out that it's multi-region. So as you know, you deploy resources to a resource group that's deployed in one region, but the resources within the template itself, they can go across different regions. So you're not limited to deploy into a single region only. So deployments will take place into a resource group. I just have a few slides to call out a couple of things regarding resource group here, because that's something you would have to deal with no matter what. It's the container for one or more multiple resources. And as I said earlier, the resources can exist in one resource group at a time only. The resource group can span regions, meaning that the resources within don't have to be in the same region as the resource group, and also can span services. What we are introducing, well, basically have introduced, and it's kind of an ongoing effort from our side, is to ensure that whatever resource you have in Azure, you're actually able to move between different resource group and subscriptions within the Azure AD tenant. So if you have deployed a virtual machine to resource group A, but later find out that we're making some changes from the org perspective and we need to move things around, you should be able to do that as well. So this is a question we often hear from customers: should we have a single or multiple resource group? Well, it all depends, I would say. You might have your own preferences when it comes to this. So in this deck, I basically have two examples One is a single resource group where the intention is that every resource within this resource group is likely to share the same common life cycle. So you can look at this as either a deployment of a specific application that you need to have in a different, in a single resource group. And if you make changes to potentially all the different resources within. We also have a concept or scenario, more specifically, around multiple resource groups. So below you can see that the example shows we have a resource group for the storage account or storage accounts in plural. We have a resource group for the front-end virtual machines, the same for the back-end virtual machines, and we have a resource group for virtual networks. So this is something we see very often in large enterprises where they have their own teams responsible for all the networking artifacts within Azure. They might manage any hybrid connectivities. So only qualified personnel will have access through RBAC to that specific resource group. However, the virtual machines, in this case, the backend that might run SQL or some other things, they might even have subject matter experts that need access to that specifically and can manage and operate those workloads, and so on and so forth across the different resource groups. So again, you can have multiple different designs, and in some cases that might affect the way you are designing your templates as well on how you are creating the resources and stitch them together. But at least these are very common as we see when it comes to design of resource groups. So Azure Resource Manager supports both imperative or declarative requests to Azure. In comparison to Classic or version 1, it only supported imperative way of deploying resources, which very often led to complex PowerShell scripts and hopefully with a lot of error handling, because it was likely that you ran into some issues, especially if you had to redeploy or rerun that particular script. With Azure Resource Manager, you can use both. So if you prefer to have a PowerShell script running imperative calls to Azure, feel free to do so. However, we also have a declarative approach using templates that we'll dive into. And basically this slide shows the script in the upper, and below we have an empty skeleton of the JSON in order to create templates and the declarative deployments in Azure. So this will introduce us to the first demo we have to showcase the difference between declarative and imperative. So hopefully you are all seeing the same as I do now, which should be visual code. What I have here is just some easy few lines of PowerShell commandlets, essentially, that will go and instantiate the different resources required in order for me to create a virtual machine here. So as you can see, there's quite a few lines of imperative calls being made. So I will run this now. And the important thing to call out is that I have actually already executed this script once. Again. So it should soon throw me an error if I got this right now. Let's just close this one. Let me give it one more try. The scrolling was, all right, let's see here. Apologize for that. So as you can see, we instantly got an error saying that the storage account named imper01450 is already taken, right? So for me to have this successfully deployed, I need to add some error handling to that specifically. So I'll just cancel this and clear the screen. And let's move over to the declarative approach. So here I have an ARM template with a bunch of parameters and a few variables as well. But more importantly, we have several resources that are declared in this template. So essentially what I'm doing here is to deploy the same set of resources only in a declarative way using ARM templates. So we have the storage account, we have the virtual network, the public IP addresses, and so on and so forth. And as you can see, as I called out earlier, we also define the dependency graph. So we create the right resources in parallel whenever possible, but we also have dependencies so that the virtual machine will get created once we have the storage account and the network interface already created. So let's try to deploy this template. And as with the previous demo for the imperative call, it's worth to call out that I already have deployed this. And you can see it iterates through the resources I have declared in the template and verify that it either exists or there isn't any updates. So if they wouldn't exist, it would go ahead and create the resources. If there are no changes, it will essentially just verify that the state is in a desired state and return success. So a few seconds later, we have a successful deployment of this particular template. So if I now go over to the portal, you can see that I have two resource groups here. The one says imperative 1 contains all the resources created with the PowerShell script. You can see there's no deployments associated with its resource group since it was imperative calls. If I go to the declarative resource group, you can see we have basically the same set of resources. We also have a deployment referencing the template I just showed you. It took 23 seconds to verify that the resources were in its desired state. And here you can see the statuses of those. So that was the demo of imperative and declarative. So hopefully all can see the screen. I trust you, Ravi, to shout out if that's not the case. So please let me know. I'll just continue. Okay, so we quickly had a look at the template, and if that was the first time you saw it, I apologize. It might be overwhelming at first, but I want to talk a bit about some of the template language expressions we have. So ARM has been around for a few years now, and obviously since day one, we had support for parameters. We had several functions you could use, such as reference, where you reference a runtime state of a different resource. It might be in the same deployment, in the same resource group, but it can also be a resource in a different resource group. Other functions you might have been using, if you're familiar with templates, is the resource ID, where you points to a specific resource in Azure. We have subscriptions. We also have variables, which is commonly used to simplify the language expression throughout the templates and make it easier for you to author and reusable templates. Some of the new things we have introduced this year is a bunch of new functions, essentially. We now have set functions. We have comparison functions that's not in this slide deck. But more importantly, we recently added support for conditions as well, and some new logical operators. So I have prepared a demo for this to show how this essentially works and walk through a pattern that hopefully should be familiar to those of you who have tried to implement conditions before. So going back to the demo, I have a template that I basically talk a bit through before we actually explore and see what's going on. So if you have ever worked with templates and wanted to implement some sort of conditions, there's only been one way where you could do that. And that's been through the usage of nested template deployments, where you have this, let's say, the main template that you actually deploy, and within that template you have what we refer to as the new or existing pattern. So depending on the selection of parameters by the user, that would result into a string that was created based on the input parameters and lead to a specific JSON file. So typically the selection here, if you said production yes or no, that would lead to a string that pointed to a template with a name matching the selection of parameters. So a nested deployment would kick in, go to that particular template that you have referenced and do a deployment. If you selected the other option, no, in this case, that would indeed go towards a different template. And in many cases, we saw that customers ended up with a lot of empty templates just to avoid that the deployment would fail. So Azure Resource Manager, as you probably know, is deterministic. So there's no randomness involved here. And that's why we have now introduced deterministic conditions as well. So instead of me having at least 3 different templates to support conditions, I have now reduced that to a single template, as you see here. And what this essentially will do is to let the user opt in and say whether the virtual machine, which we will deploy in this case, should be in production. We have 2 allowed values, which is yes and no. They can also select whether the platform should be Windows or Linux, right? So it's not super fancy, but then they can deploy this template. They make a decision whether it should be production or if it should be Windows or Linux, right? So yeah, it does a bunch of other things as well, such as connecting to an existing virtual network. And if we go and look at the different resources we have, let's see where it is. We have this resource, which is the availability set. So a way for us in this example to determine if this virtual machine should be in a production, we want to ensure that we have an availability set, since that needs to be created up front before adding virtual machines to it. So we have now introduced a condition property at the resource level. So here we use a comparison function of equals. So if the parameter of production results in yes, then we will actually run through this resource when we deploy. Okay. If the answer is no, this resource will simply be ignored. And as we move along, you can see on the virtual machine resource itself, if this matches Windows and for the parameter selection, it will go ahead and create this virtual machine. And here we also use logical operator and together with comparison, and verify that if the virtual machine is set for production, yes, and the platform is Windows, we will essentially reference the availability set that is being created. And we basically repeat the same pattern for the Linux instance as well. So if they select Linux, we will then create this resource. And if it's in production, we will also associate with the availability set. So let's see if this actually works. I have a resource group where I will now deploy the Linux virtual machine. That shouldn't take long because, as you know, I have cheated a bit, so I have already deployed it. And it will just verify that things are in its desired state in that case, and we should have a successful deployment. While we're waiting for that to complete, I'll also call out the second deployment that we will do. So obviously this deployed a Linux. You can see the name of the virtual machine. You can see that the selection we did was production, yes, and the platform was Linux. and it deployed successfully. And I will do the same for Windows as well. So it goes into the same resource group, and we should now have different resources in that resource group. So let me go back to the portal and flip to the conditions demo. You can see we have the we have a virtual machine for Linux, we have one for Windows, and we have IP addresses and so on and so forth. So if you click on the deployment, you can see we have two different deployments, one for Linux and one for Windows, and they both are successfully completed. So hopefully you got an impression now that, hey, we have condition. It actually works as well. So you can go back home and reduce the complexity of your templates quite significant, I would say. Okay, so obviously we have more advanced template scenarios as well. As already called out, we are able to extend. So whether you deploy a virtual machine or app services or SQL databases, you can use extensions. So you can have ARM to interact with the for the virtual machine, the guest operating system. So you can run scripts and have that successfully executed as part of your deployment as well. So you can have your entire application deployed, not just the topology. We also have support for copies. So if you need to iterate through multiple resources of the same resource type, you can easily do so. We also have nested templates, and I have a few slides for that as well. And we also now support conditions and logical operators. So for some of the more complex applications using templates, you might have seen a similar design such as this, where you have a master template that is used to invoke the nested templates depending on the selection you made. And you have different teams within the org that's responsible for different templates, such as the networking team is responsible for any networking artifacts in this area. And the same goes for the compute, application-specific workloads, and so on and so forth. So these are all checked into, let's say, a GitHub repo or any other source code handler. And you can then stitch things together to become really complex. And you have the deployment graph that goes towards the different resources depending on your selections. And of course, each and every template can also share state in this pattern. So you can actually, it can become very complex, but at the same time also very powerful. So some of the, so this was all good and all great for complex application scenarios. However, some feedback we've gotten over the years has been, how do we essentially instantiate not just the entire application, that complex application we have end to end, but more towards how do we instantiate the entire topology for the entire infrastructure, which should also include management as part of that conversation as well. So one thing we added support for back in May was cross-resource group deployment support. So if you have been working a lot with templates, you might know that you were limited to deploy only to a single resource group as part of that process, but you can now actually opt in and deploy to multiple resource groups within nested template deployment. So let me jump back to the demo. And for this demo, I'll point you to a template essentially that we made for you to go out and explore how to manage and have well secure and manage infrastructure in Azure using the different OMS services we have. So please note that this template should only be used for demo purposes. However, if you want to explore and see how things are constructed, you can, of course, go and do that. It's available on GitHub, and I will browse to GitHub to explore a bit. And we have the Azure deploy JSON, which is the main template. This is the template that you will deploy. And as you can see, we have a bunch of nested templates here that will also be deployed as part of the process. So if I go to the Azure deploy and go into first explore the variables. So here you can see we are pointing to the different nested deployments throughout the deployment, such as for the workspace, the automation account. We also deploy virtual machines that will be attached to the different management services. And for us to achieve that, we need to use nested deployments, because you don't want to end up having all the management artifacts and also the workload in a single resource group, because the reality shows that the persons managing the management services are not necessarily the same that will have access and deploy this specific workload in Azure. So for the virtual machines we deploy, we introduce support for resource group at the Microsoft Resources Deployment Resource. So now you can specify the resource group where this nested deployment should take place. So in this case, we have a resource group where we will target the virtual machine workload, and the template will spin up the resources in that particular resource group. So once you have deployed that, you will essentially end up with something like this. You will actually get a customized dashboard. You can see we have a resource group containing all the management services and artifacts we have, such as the OMS solutions, a bunch of runbooks for ASR, automation account, and so on and so forth. So now we have a dedicated management group for, a resource group for the management resources. And then we have the workload resources are in their own dedicated resource group. And if we explore the different management services here, you can see that all the virtual machines that we are creating with this deployment will end up being protected using Azure Backup. We will have them associated with DSC, and we will also have them monitored using the OMS extension for log analytics as well. So hopefully you see that we are making some great progress here. We believe that with cross-resource group deployment, you should even be able to do more advanced stuff when it comes to deployment topology you want to implement in Azure across subscriptions and so on and so forth. So if you haven't tried it out, I encourage you to do so to see if it unlocks some of the scenarios you have been struggling with in Azure. Okay, so moving forward, for the deployment, as you saw, if you make a deployment into using templates, you will end up having a deployment resource itself. That track the template execution, it's actually created as a resource within the resource group, and we also support nested deployment. So once you do that, when you create templates to deploy your resources, there's two ways to establish dependencies. The perhaps most common is to use depends on, which is a way for you to automatically define the deployment graph of the resources, and also to use reference, which is a way to implicitly define the same. So in this case, you can have an app service plan that will deploy first. We then have websites. We have autoscale settings that takes dependency on the app service plan. And then you essentially see that we have a bunch of other components being instantiated as well with the right dependency graph established. And then it all completes. Okay, so I want to call out that if you want to invest into templates, you should also explore what are the extensions we support and provide. So we provide many first-party extensions, such as custom scripts, such as PowerShell DSC and OMS and so on and so forth. But obviously, we also have support for third-party extensions. So I don't have a complete list on top of my head right now, but we have this documented, so you should be able to find the information. So depending on the workload you would instantiate, you might have different preferences when it comes to how you do so. In a virtual machine in this context, where you use extensions, in this case, whether it's PowerShell, DSC, or Chef, to configure your applications as well. So this is a good way to deploy this end to end. Okay, so I just want to check in the IM window and see if there's any questions coming. To take the pulse on that. Just around the, okay, there are some connectivity issues and so on and so forth. Okay, great question, Ravi. I'll put that on the parking lot and save it for later once we have completed the deck, and I'll talk more about that. Thank you. So the next topic is basically control, IAM, and governance. So far we have seen that, hey, you can use Azure Resource Manager to easily declare the golden state of your services, your workload, topology, and so on and so forth in Azure. And we have a rich template language that you can use. We also introduce conditions, just as a reminder, so you can go and party with that afterwards. So, but I also want to call out that with ARM, which is the front door of everything in Azure, essentially, that's also a good place to have control, IAM, and governance. So I'll talk a few minutes on some of the capabilities we have here, just to ensure that everyone is on the same page. So one thing you can do with Azure Resource Manager is to add tags to your resource groups and resources. That's something I encourage you to do if you have multiple subscriptions, if you need to, let's say we have many good use cases for tags, as you will see in the next couple of slides, but that's something that also can be implemented as part of your templates. So you can specify tags during deployment. We also have role-based access control, which enables fine-grained access management for Azure. And by using RBAC, you can segregate duties within your different teams and grant only the amount of access to users that they need to perform the job. There's also a lot of auditing in Azure and ARM. And with audit logs, you can easily retrieve that using PowerShell. You can use the portal to understand what are the operations going on in Azure. And also there might be scenarios such as the management resource group I just showed you. If that's something that will serve multiple virtual machines throughout subscriptions or across subscriptions, I think you would hate to see that resource group or resources within would be accidentally deleted. So resource locks is something we also have, where you can lock down a resource to either be read-only or cannot delete for that scenario, to avoid that things get accidentally deleted. So we also support that. And last but not least, we have solid policy enforcement system in place in Azure through Azure policies. So the platform itself is an allow by default system, where RBAC, on the other hand, is a deny by default system. So by policy, you can easily implement a different set of rules that will ensure the right behavior of your Azure resources, as you will see. But first, let's start to talk about tags. So tag is a name value pair that you assign to resources or resource groups. So typically examples here would be cost center, author, production tag, and so on and so forth. So you more easily can locate the resources after the fact and understand what they are doing in the right context. So each resource can have up to 15 tags. That's the limit as of now, and that applies to both resources and resource groups. So here's a list of some tagging tips. We see generally a large usage of tags when it comes to environments, roles, departments, and the responsible party as well. I'm pretty sure you also have your own ideas and creative ways to use tags, but these are the most common. For role-based access control, this is a way for you to secure who has access to the different scopes and resources, and what are the actions they can take within this scope. It's assignable to users, groups, or service principals, and we also have a bunch of built-in roles for each resource provider that we ship, which should make it easy for you to get started to control access. So role-based access control, and this also applies to logs and policies. We have the following hierarchy in Azure. So each subscription in Azure belongs to one and only one directory. The resource group belongs to one and only one subscription, and our resource belongs to one and only one resource group. And access that you grant at the parent scope is inherited at the child scope. So if you give me the owner access at subscription scope, I will actually have owner access across all resource groups created within the subscription, and of course the resources as well. So that's why you need to think through this carefully when you plan the RBAC design. So this is another slide basically showing the exact thing I just said. We have the subscription and the subscription ID. We have the resource groups and the different resources. And this is where you can set RBAC at these different scopes. For policies, that's something interesting. So I actually have a demo for that as well. I want to ensure that you are aware of some of the things we recently did there. So policies until recently have been something that's been kind of hidden in the platform, because the only way to interact with that was through the API directly or using PowerShell. So a policy lets you define these customized rules, if you prefer, that governs the shape of your resources. So again, just as RBAC, you can assign a policy at either subscription or the resource group scope, and things will be inherited by default. When you have a policy, you will either deny the request, or log the request, and also in some cases you can append the request. So if you have a append policy for tags in this example, and someone deploys a resource and they don't have the required tags specified for those resources, you can use resource policies to append those tags automatically to those resources. So we hear from customers in this space that they need granular control over the Azure resources for things like geo-compliance, cost control, configuration best practices, security, and so on and so forth. And they also would like to have an IT pro-friendly tool which is seamlessly integrated across the platform to enforce these policies. And they also want compliance statuses. And I want to talk a bit about the capabilities we have today, where we have now introduced a policy catalog with a bunch of built-in policies that you easily can consume at the preferred scope. We also have eventing for policies. We have support for parameters. So in case you need to create a new policy, but you don't want to assign it, you don't want to create multiple definitions to support different values, which was the case earlier. You can now have support for parameters, so you can reuse the same policy definition over and over again. And last but not least, we also now have UX support. And a policy looks something like this. We have the condition. We can also use logical operators within. And then we have an effect. So in this case, we have a policy that says if the field location on that particular resource, in this case, all resources, is not in North or West Europe, then we will deny the request. So regardless if you go through the portal, if you make an imperative call using PowerShell or CLI, or do a template deployment, the policy assignments will always be validated. So in this case, it will deny the request if this is not the case. And I have a bug in my slide deck, so the demo here should obviously not be conditions over again, although you might really prefer that. But let's have a look at the policies. So going back to the portal, I'll drill into my subscription, and a couple of months ago we added policies to the user experience. So now you can go into your subscription or any resource groups in Azure, and you will have the policy view here. If we look at the policies we have available, which means the built-in definitions, but also the custom policies that you create, they will be listed here. So I will now make, let's go ahead and actually create a policy to show you how you can get started with that. So the first thing you can do is to define the policy itself. So right now I'm doing this in PowerShell. I have the JSON here, but that can also be a JSON file that you reference later. I specify the condition and the effect. So in this case, if someone tried to create a virtual machine that's not in one of the allowed location that you will assign, then the effect will be deny. For the parameter, this is the parameter variable that we will also use together with this definition. And I will then create a new policy definition that will light up in the portal after the fact. So let's go ahead and just run through this. And if I go to the portal now, I should have the compute location. So this is the policy definition I just created. You can see we have, well, it's basically the same one that I just had. So I can now go and assign it. Selecting the compute location, I'll select a few regions here. Let's do East US and North Europe and West Europe. Give it a name and ID, and I click OK. So with that click, I am now ensured that no one at this subscription can deploy resources of the virtual machine type to any other regions that I specified. Of course, if I assign this policy at the resource group scope, other folks could, of course, go in and deploy resources to other regions outside of that scope. But this is a way to ensure governance at subscription scope with a few easy and simple steps. So with that, we have around 6 minutes left for any questions. I just want to make a quick recap that we looked at during this session. We saw, we got an overview of Azure Resource Manager, what it does, how it interacts with the different services we have within Azure. We explore what it means to do imperative versus declarative requests to Azure using PowerShell and templates. In that example, we also had a look at the some of the new capabilities in template language expressions, such as support for conditions, logical, and comparison functions. We then had a look at the support for cross-resource group deployment, which should help you to make more complex topologies available for you to deploy using templates. And last but not least, through the authorization, governance, and IAM aspect of ARM, we had a look at RBAC policies and tags as well. So hopefully you learned something today. I'm glad the demos worked as expected, and I want to thank you all for joining. And if you have any questions, now is a good time. Okay, so let's start. We have a question from Jonas here. Are there any resource providers currently unavailable for deployment via ARM, or even better, is there a roadmap showing what's missing and when to expect them to be available? So, any RP that we have within Azure Resource Manager, and depending on the resources, of course, should be deployable using ARM. I'm assuming you're talking about templates here. You might have experienced that you are sitting Visual Studio or Visual Code to author a template to create certain resources, but you don't get IntelliSense. If that's the case, it simply means that we haven't published the put schema for those resource types yet. So unfortunately, tooling won't help you, but we have, actually, I want to call this out. We have a good documentation right now. So if you need to look at any, if you want to see the references for the different resource types we have, let's take an example and say Cosmos DB. You can click into the database account in this case, and then you can see the template format to create that resource. So it's by essentially following the different resource provider namespace that you're dealing with, such as automation. You can see we have automation account, which is the top level resource, and then we have runbooks. You can then see the JSON format that we expect as part of the template request. So hopefully that answers your question. Ravi, you had a question about validate existing templates for applicability on Azure Stack. I'm not sure if we have published documentation around that or best practices. I do believe that there are some guidance in both the Azure Quick Start template repository, but also in the Azure Stack Quick Start template repository for the applicable resources that you actually can deploy across on how to author the template so that the resources can, so you don't have to deal with multiple templates. So I would recommend to have a look into that. I'm sorry, I'm not fully up to speed on everything within Azure Stack, but we should have some guidance on that in the repos. So we have a couple of minutes left. If you have other questions, feel free.
I just have one more question. Let me just put it on the IM first. All right.
Okay, great question again, Ravi. How do we ensure that the infra is functional as per design? Do we have any hooks or events in ARM that we can use to trigger tests? So I guess it all depends on what you are deploying here, but we have, well, there's multiple notifications going on in Azure when you do deployments. So you can either plug into the audit log to get the operation you're looking for to further expand and take action based on that. And we also recently announced Event Grid, where you can build easily integration across to kind of do the different scenarios around a deployment. I'm not sure if that answer your question, but there might be different scenarios you might look into for that specific.
Sure.
And how to easily detect what version of the resource provider to use. It depends on the resource type, I would say. We have, there's different ways to get all the available API versions we have for the resource provider contracts. And from there, you can see what's available. Some customer prefer to always use the latest, but potentially with each API version, there might be breaking changes compared to the other API version you were using. So always validate that your template works. Yeah, if we have put schemas published, it should be documented there as well. All right, any last questions? Going once, going twice. Okay, with that, I want to thank you all for joining. I unfortunately forgot to bring myself a cup of coffee to this session, so I'm exhausted now, and I need to fix that. So thanks again, Ravi, for hosting. I really appreciate the community attending this, so thanks again.
Thank you, Kristian, for a great session. And folks on the meeting, we can wrap up now, and we'll have the recording by later this evening, India time, on the link I mentioned in the IM chat window. Thank you, Kristian. Thank you, everyone. Have a good day. And